function for the all square root parent functions. F of x equals square root of x. Again, if you don't know how this function looks or how the graph looks, your calculator is your friend, right? So let's go to my calculator, to our calculators. Let's do for you. So let's enter this function into our calculator. Y equals square root, which is the second, here, x to the power of something. Of x, square root. And then
You went really fast. You go back.
I went really fast. So y equals, the square root is right here. So do second, and then, right, so square root, and then x under the square root. And let's graph it. And I need to adjust this one. So you see the function, it looks kind of like half of the parabola playing on itself, right? Which makes sense because square root is kind of the inverse of the x squared, right? The opposite. Doesn't matter. So to transfer our graph from the calculator to the paper, of course, we need to note some of the good points. So we go to the second table. Am I not doing something right? Okay, so you can go to second table. For some reason, it's not working for me. Go back to your y. Oh, y equals. Yeah, my calculator is.
So you guys know what to do. Go to the second
Yes.
graph and go to your table and then get some nice points, not the errors. Get your
Right.
points after the errors and let's graph that.
Okay.
Right. So by the way, why do you think we have all those? I need to reload it. Yes.
Because there are.
Sorry. Okay. There we go.
Thank you.
Should be able to.
Right. So that's why we don't want to take any of the points with the error in the y column, and we only want to include the points that have nice numbers. So the starting point of this graph is 0, 0. That's where our graph starts. Right? So 0, 0. And then we want to take some of the good points, not the decimals, but good points on the right of the 0. So some of the good ones would be what? 1, 1, and then 2, 4, and then 3, 9, and so on. Correct? Yes. So 1, 1, let's plot them. 2, 4. No, what am I talking about? These are pronouns switch. Oh. Yeah, of course. I'm doing square in my head, but I should be doing the square roots in my head. Right? So 4293 is the square root. Right? So I'm like, that's still good parabola. Okay, 4, 2, and then 9, 3. And let's connect them. So the starting point of this graph is 0, 0. What is the domain of this graph? So domain is which values of x I can choose, right? Where my function is defined. Yes, you. 0, positive, infinity. And do I have bracket or do I have parentheses? Bracket for 0, right? Because 0 is included, right? I can do square root of 0. What about the range? What is the range of this function? Luis, what is the range of my function? 0 to infinity. Right? Because that's where my function lives if I think about y values. Those are all the values of y that I can get from this function. Yes, it's bracket for the 0. Right? Because the starting point has the coordinate y equals 0. So 0 is included. Okay, so what are my intercepts? Y-intercept? 0, 0. What is the 0 of this function? Zeros are x-intercepts, right? 0, right? So either like this, 1, 0, or just with this is the point, 0, 0. Increasing interval. Where does my function increase? 0 to infinity. Everyone sees this?
Yeah.
Right? So remember, this function doesn't really have any maximums or minimums except the starting point, right? So there are no turning points, right? No local maximums, no local minimums. So, yes. No. For intervals, we'll only have parentheses, right? So there are no turning points in these functions, right? There are no maximum minimums like we used to see, right? So the function is always either increasing or decreasing forever, no turning points. So do we have any intervals that are decreasing? No. Function is always increasing. Right hand behavior. As my x increases, goes to the right, what happens to my y? Y also increase, so the y goes to infinity, no stopping there. Questions about this?
Are you going to the rest of the table?
No, I don't have to, right? Because the rest of the table is outside of my graph.
No. I mean, like,
I mean, I can, but 25 pass, it doesn't matter, right? Okay, so whenever I have not the parent function, but like this function change, transformed without transformation, the tip for graphing, just find that starting point and then choose few points on the right of it, the good ones.
60, skip 64.
You don't have to include all of them. It's just some points.
Uh,
Okay, questions about this? Next one. The cube root. The simplest cube root function is the cube root of x. No coefficients, no transformations, just cube root of x. Okay, so let's enter it in the graph. I mean the graph calculator. See what happens. Y equals, and now instead of the square root, I want the cubed root. So two ways to enter, right? The first one is just math. Go to number 4. There is your cubed root.
press enter.
X. Or if I forgot about the math and where this cubed root lives, what could I have entered? X to what power?
3.
Right? So instead of these, I could have entered x to the power of what?
3.
No.
No.
Cubed root. 1/3. 1 divided by 3. Right? Because that's the simplest. Okay, let's calculate the. Oops. Everybody got that?
Yeah.
Okay, so again, if I go to my second graph to see the table, now you don't see any errors, right? I just see some negatives, and if I scroll down, I'll see some positives, a lot of decimals, ugly numbers. But of course, I want to choose the good ones, right? Meaning that I don't want any decimals, only integers. So if I go back to my graph, you see how this graph kind of has a center, right?
Hold on.
It's almost symmetrical around 0, 0. Not exactly symmetrical because, you know, one arm is up and one is down. But there is like center, right? At some point, it's almost vertical, right? See that? So the point where the graph kind of changes the slope, I guess. Slope becomes vertical for just like a moment. It's called the center. So the center point is 0, 0. Not the starting point anymore, but center point. If you want to take the graph, transfer it from the calculator to the paper, you always find that center point where the graph kind of changes.
The line goes through 0, 0. Is that what you're saying?
Not the line. The line does go through 0, 0, but I'm talking about that center point. You see how this is center, kind of, right? Like, not really symmetrical, but almost kind of symmetrical, right? So you make a note of that center point and make sure you find its coordinates. So the center point for this graph is 0, 0. So I put my 0, 0 in the middle of my table, and then I need to choose some points above it and some points below it, right? So meaning that some points on the left of the center point and some points on the right of the center point. So the first one on the left, the good one, is -1, -1, right? The first one on the right is 1, 1. If I don't have my graphing calculator, I can also do this manually, right? So what do you think would be a good next one after 1, 1? It would be 8, 2, right? And how do I know 8 is the perfect cube? So I can take the cube root from 8, and it gives me a nice integer, right? And then the next one would be what? Huh?
27.
27, right? Because 3 to the power of 3 is 27. That's how I know, right? And if I go back up, it would be -2 to the power of 3 is -8, so -8, -2. And then the next one would be -27, -3. Right? See what I'm doing here? Trying to figure out the good point. So I'm starting with y to get good points for x. Okay, so let's plot them. 0, 0 is my center, and then I have 1, 1, and then I have 4, 2, and then I have 9, 3. And kind of symmetrical, so -1, -1, -4, -2, and -9, -3. I connect my points.
Where'd you get -9, -3?
It's 27.
Oh, negative
It's
8.
8,
Yeah,
too.
that's true. Oh, I'm sorry. Negative. Oh, I'm sorry. Yes.
It's 8.
Yes. It's 8. Oh, so 0, 0, 1, 1, 8, 2, 0, 0, -1, -1, -8, 2. Yes. Thank you. Attention that. Okay, so now what is the, and right now it makes total sense why we don't have those errors anymore, right? Because I can take the third root of negative numbers, right? I can take third root of any number. That's why we don't have any errors. Okay, so what is the domain of this function? Hannah, what is my domain? Domain is about what values of x I could choose to plug in here. So what are the values of x for my graph gives?
-27 to 27.
Well, yes, in this table, but I could continue this table, right, forever and ever.
So
So it's
negative infinity to infinity.
what? Yes, negative infinity to infinity. There are no restrictions on this function. I could choose any number instead of x. Plug in, get y. So what is the range? Range is all about y values that I could get, right? So whatever numbers I could get is this y column, yes. All real numbers, so negative infinity, infinity, right? So I start from the bottom, go up, figure out where my graph is, everybody. Okay, so what is my y-intercept? 0, 0. What are my zeros? 0, 0, the only 0, right? The x-intercept. Leah, are you writing? Or you just remember everything? Just remember it. Good memory, lucky you. Okay, increase in interval. There is no increase in interval?
Maybe there is.
So what is increase in interval? Where my function goes like this, where the slope is positive, right? From 0 to 2, that's it? What does happen here? Function goes up,
Probably from 0 to
Right.
3 is the increasing interval.
so it goes up here, and what happens here? If I travel from the left to the right, my y value go up or down? Up, always up, right? So when is my function increasing?
0 to 30.
Negative infinity to infinity.
Negative infinity to infinity, right? Remember how we did, like, for the polynomials, remember how we talked about, like, increasing, decreasing? We found local minimums and local maximums, right? Remember how we did that? And then all those local minimums and local maximums, we call them turning points, right? So turning points meant that the function goes from being decreasing to increasing to decreasing to increasing to. There are no turning points like this here, right? So this function is either always increasing or always decreasing. There are no maximums and minimums like these ones, right? So the function is either always increasing or always decreasing, and this one is always increasing, right? Because you see like the slope is positive for the most part. Make sense? Okay, so decreasing interval? None. And behaviors. What happens to my y as I go all the way to the left? It decreases, right? And how much it decreases? Y goes to negative infinity. Right and behavior. As I increase my x, what happens to y? Infinity. Goes up. Question?
Are they just all gonna be 0?
No, so now we talked about these parent functions, right? The simplest one. And now we will start adding transformations. And that will change it. Just
Looking all the same.
yeah. Okay, so remember our transformations, right? We talked about transformations and we talked about quadratic functions. We talked about transformations and we talked about absolute value function, right? So this is the same idea. We could, there's a question now. Okay, so this is the generic form of any square root function, and this is the generic form for any third root function. So, you know, the example would be y equals 2 square root of x plus 1 plus 2, right? What is my a here? 2, what's my h? H? Negative or positive? Negative 1, right? Because it's minus h, and I have plus 1. And then what's my k? Plus positive. Okay. So how is my parent function changes after I add that a in front? What does this a affect? Everything. What does this 2 mean here?
They are multiplying by 2 to have.
Right. So what did we say it is? When we talked about transformation, stretch and compress, right? So this number a affects the size, or yes, size of the function. Right? So it's either compress or reflect. When a is greater than 1, we say the transformation is called what? Stretch. Right? So every value of y coordinate gets either doubled or tripled or whatever, multiplied by a. So when a is between 0 and 1, we call that transformation compress. So we compress the y value. And when a is negative,
We flip it.
yes, reflect. What about h? H? Right or left? So when h is positive, h is greater than 0.
Left.
Do you go right or left? Left, yes. No. Left?
Yes, it's left. It's positive. It's left.
Oh, okay. So here is the confusion, right? I know what you mean is right, but let's just go by the notes. Minus h. So when I do minus positive number, I have like, this is minus minus. So this one means h is negative. See what I mean? So when h is positive, I will have like
When it's
square root of x
positive,
minus
it goes
1.
to 1.
Would it be left or right? This one,
But
left
they-
or right?
Saying when it's positive, you're left.
H, when h is positive. Minus h. So here h is positive. My h here is 1. Right? When I have this transformation y equals square root of x minus 1, my h here is just 1. It's positive. Right? So here, what is the transformation here, left or right? This one is right, right? So when h is positive, you go right. Right? Correct? Yes?
We can also write x minus h is what it would look like.
Right, so example, let's do example. Example, square root of x minus 1. F of x equals this. Right? So
So,
this would be h equals 1, so h is positive, goes to the right. Hate calculated, right? So great confusion. Okay, so when h is negative, so h is less than 0, with the example of f of x equals square root of x plus 1. Right, so it's minus negative 1. H is negative. The function goes to the left. Very messy. Right? Okay, so we say that the h affects the vertical or horizontal shift instead. Horizontal shift.
You could write direction.
Horizontal. That's what I need. Horizontal. Okay, I know like this is a little bit confusing just because of the way the notes are written, but I know you know it. Okay, so what about K? What does K affect? What kind of shift?
Up or down, then.
Vertical. So when K is positive, the graph is moved up or down? Up. And when K is negative, the graph moves down. It's more straightforward. Okay, moving on. So here is we are asked to do the graph, right? First of all, we can always use graphing calculator, but we still need to recognize transformation. So let's start the transformation. My parent function is just square root of x, right? Y equals square root of x. What are the transformations that we see happening here? Jaden, don't sleep. What are my transformations, Jaden? 3 square root of x minus 1 minus 4. Stretch 3. Right 1. Down 4. Okay, so the parent function looks like this, right? Starting point was at 0, 0, and then 1, 1, and then we had 4, 2, and 9, 3, right? So this is my parent function. Now I'm talking about the new function, the one that was transformed. So the starting point from 0 to 0, 0 moved where?
down.
Right 1, down 4, right? So stretch does not affect my starting point because if I start here, times y equals 0, 0 times 3 is still 0, right? So the stretch does not affect my starting point. So right 1, down 4. My new starting point is 1, negative 4. Right? And the rest I can graph either taking one point at a time and applying transformations, which I will do now, or I could use my graphing calculator, right? Graph it, find the good points, plot them, connect them.
You can grab the function that's on the top of the page.
Yeah, you can do that, right?
Yeah.
I will just go point by point. So the next good point on my parent function was 1, 1. So stretch brings it to 1, 3. And then down 4, 1, 2, 3, 4, and then the left one. It's, no, something wrong. Why was it wrong? So 3, 1, 2, 3, 4, and then no, it's still right. Wrong way. Oh no, right. Okay, so here. And then the next one was 4, 2, so it goes to 4, 6 with the stretch, and then right 1, and then down 4, 1, 2, 3, 4. Right here becomes 5, 2. And it's pretty much enough for me, but I'll do one more. So 3 times 3, and then down 4, 1, 2, 3, 4, and then right 1. Now it's not enough. Does this look the same if you use the calculator? Yeah? Looks the same? Anyone use calculator? Are you sleepy?
No.
Does it look the same? Oh, where did I make a mistake? How does it look?
Maybe I didn't.
Oh. Let's see. Y equals? Oh, your negative 4 is under your root. It should be out, right? Okay, questions about this? Come on, more energy.
Can you go back?
Huh? Back? Okay. The next function, negative third root of x plus 2. What is my parent function? What is my parent function? Anyone? Teddy, what is the parent function? Huh?
That equals y equals square root of that.
Square root of 3?
Oh, just I'm not.
Root 3?
Yeah.
Root 3x? What does it mean, root 3? Huh?
Equals the cube root of x.
Yes. Third root of x. That's my parent function. The simplest function with the third root, right? Third root of x. So let's plot it. Remember we did plot it before? This is my parent function, right? What was the center of my parent function?
0, 0.
0, 0. So this is my center, right? Okay. So what are the transformations that we see here in this formula? Lillian, what are my transformations? Reflect. Is it left 2? Is my plus 2 under the square root? I mean third root? No. So is it h or k? Up to. So two transformations, one reflect, the other one is up to. So what do you think is my new center? Does the stretch affect my center? Or reflect? Does the reflect affect my center? No, because the center, the coordinates are 0, 0, right? So reflect means reflect around the x-axis. Nothing changes. And then up 2 brings me to 0, 2. So my new center is 0, 2, right? Is this right? Yes. Okay. So now we can graph this function either using our calculator or just taking the points from the original graph and applying transformation. So I'll do the second one. Somebody should take the graphic calculator and check us. So I'll take 1, 1, right? The point that I'm taking from the parent function is 1, 1. Reflect brings me to 1, negative 1, and then plus 2 gets me back to 1, 1, right? Doesn't change. 8, 2, yes.
Why is that a one?
Oh, because I already did center, now I'll take this one, and then I'll take that one, and then I'll take a couple more, right? There's only like 1, 2, 3, 4, 5 good points on this graph. Okay, so from 8, 2, the reflect becomes 8, negative 2, and then up 2 brings me to 8, 0. Right? Negative 1, 1. So reflect brings me to negative 1. I mean, I start with negative 1, negative 1. Reflect brings me to negative 1, 1. And then up 2 brings me to negative 1, 3. Right? And then negative 8, negative 2. Reflect brings me to negative 8, 2. And then up to negative 8, 4. So here are the points for me too. Something like this. Questions? Something wrong? Is it minus or negative? Questions? Okay. So now without the graph, how does the graph negative, or is it not the same? No, no. Negative square root of x minus 3 plus 2 move from the parent function square root of x. Kevin, what are the transformations here? Reflect. Right 3. Up to. Everybody agrees? Next one. 1/4 third roots of x plus 3. Amar, what are my transformations? Compress. Left 3. That's right. Okay, next problem. Given the following graphs, write the equation assuming that A is 0. Right? Always three directions. We are told that A is 0.
1.
I mean 1. Yes, of course. A is 1. Okay, so what is the parent function for this one? What is my parent function? Do we recognize the shape? Eva, what is the parent function here? Is it square root of x or third root of x? Square root of x. Right? What are the transformations that we see here? How will we decide? I don't know. So my parent function should look something like this. Right? That's my parent function. So first we need to decide, is there reflection? No reflection. We are already told that A is 1, so there is no compressor stretch, right? So now we just need to decide, did we move up or down, left or right? And how many points?
Like 4.5.
Well, not really 4.5, right? Let's look at the starting point, right? The starting point was 0, 0, and now it's
Up
what?
3.
Yes. So we have up 3, left, right? And we can determine this most easily by looking at the starting point, right? Or, yeah, starting point. Starting point moved from 0, 0 to negative 2. Right? So that would give you an idea of the transformations that happened. Correct? Okay, questions about this? Okay, so now we are ready to write the equation, right? Y equals, what would be the equation if we start with square root of x and apply these two transformations? Yes, you? X. Up, left to right. So, square root of x plus 2 plus, yes. Good. You want to do the next one on your own? Do the next one on your own. What is the parent function for this one? Cubed root of x. Y equals cubed root of x. What are my transformations? Up to left one. No, not left, right.
Up forward. Looks like it goes up and forward.
Yeah, right one. Okay, so let's think about it. My parent function cube root of x looks something like this. The center is 0, 0, goes through 1, 1, and then a 2. So this is my parent, right? My center used to be 0, 0. What is the center of this new function? It's 1, 3, right? It's where function kind of, I don't know, it's kind of a center of the function, just looks like a center, right? It divides the whole function into pieces that are almost symmetrical. Not exactly symmetrical, but kind of, right? A diagonal. Right, so this is my new center. 1, 3.
So, Ms. R, we found that that's up 3.
Oh, yes, it is.
You gotta be careful.
Up 3.
Yeah, up 3.
It's like
Well, no, it doesn't even touch. If you look closely on the graph, it doesn't even go through 1, 2. Right? If you look closely, it doesn't even go through 1, 2. So it's 1, 3. Just need to be careful. Okay, so this is the new center. Right? So from 0, 0, the center moved to 1, 3, so we know that transformations are R1 and up 3. Anything else that happened to this function? It reflected, right? Because you see the end behaviors flipped, switched. The parent function goes down on the left, and the new function goes up on the left. So that's how we know that the function was flipped. So now the transformation is reflected. Are we done?
No.
No. So we need to write the equation. What is my new equation? I know my parent function and I know my transformation.
Negative cube root of x.
Negative cube root of x, what? Minus 1 and then plus. Any questions about this? Okay, then. Hmm? You want to try on your own? Okay, let's try on your own. Yes. So just based on the formula here, I know my transformations, right? Stretch to, up to. And when I compare my transformations to the graph that I got from my graphing calculator or my own, mental math, so 0, 2, and then 1 will get me 2 plus 2, 4, and then my 4 will give me 6, right? So I kind of see that it matches, right? Because the parent function used to be like this. And my function seems to be stretched out vertically. It is up to, and it doesn't move left or right. So looks good. I figured my transformations from the formula. I figured my graph from either graphing calculator or just substituting x's and getting my y's. And then I compared the two, right? And they kind of align together. So I'm good. What is my domain? Again, domain is what are the values of x that I could choose, right, and plug in. So my domain is 0, positive infinity, with the bracket and the 0. Right? Anything below 0 will get me square root of negative number, which is not defined. Errors in my table. So that's not part of the domain. What about range? What kind of y values I can get? 2 to infinity with the bracket on the two sides, right? Make sure I use the color. What is my y-intercept? 0, 2. And what are my zeros? None. There is no x-intercept. Because we start above the x-axis and then we go up, right? We never go down, never cross. So what is my increasing interval? 2 to infinity? Something is wrong with that statement. What values have x for which my function increases? Right? It's x values. So 0 to infinity. So common to make this mistake. This mistake is so common. Decreasing interval? None. Function always increases. Right and behavior. What happens to y as x goes all the way to infinity? Approaches infinity, right? The function is increasing all the way, so it goes to infinity. Questions about this? Next one. Try on your own. So first, we plug this into our calculator. We find our graph, right? We can just transform it here. Or we can do this using the transformations. So from the parent function, which is the third root of x, what are my transformations? Just from the formula. What are my transformations?
Right one down.
Right 1, down 5. That's all. So if my parent function looked like this, right, that was my parent function, and my center point used to be 0, 0. What is the new center point? Right, it moves from 0, 0, right 1, down 5. So the new center point would be 1, negative 5. Correct? 1, negative 5. That's it.
Why wouldn't it be 0
Because it's down 5. Right? Okay, so nothing else happens. It's just the whole function just moves. So I can kind of just take my good points and apply my transformations. So A, 2, and then this one, and then here. I can either just apply transformations, moving my graph point by point, or I can take it from the graphic calculator, the new points, right? So I just apply transformations. Okay, so domain. What is the domain of this function? Hannah? Domain?
Negative, negative infinity to infinity.
Yes. Range? Okay. Y-intercept?
0, negative 6.
0, negative 6. If I can see it clearly on my graph, great. If I cannot clearly see it on my graph, if I go to my table, what am I looking for? When I'm looking for y-intercept?
Looking where it says
0 should be where?
X.
X, right? So 0, negative 6, this is what I'm looking for y-intercept. Or I can just plug in 0 instead of x into my formula, right? So 0 minus 1 is negative 1. Third root of negative 1 is negative 1. Minus 5 gives me negative 6, right? Good. So 0, negative 6. Zeros.
9, negative 3.
9, negative 3, how is that 0? Right, x-intercept would have y equals what?
0.
0, right? X-intercept, by definition, is on the x-intercept, so the y value should be 0, right? You don't see it on the graph, and even when you scroll down, it looks like you never get there, right? Because
I'm gonna get there.
I'm looking for a 0 in y column, right? So this would be my x-intercept. And if I cannot find it like this, what do I need to...
It's 126.
Yes, it's 126.
Oh, you said
And
that.
if I didn't find it, just think about it. We are saying the domain is negative infinity to infinity. So the graph lives everywhere. And then we said the range is from negative infinity to infinity also, right? So the graph will increase, increase, increase. At some point it has to cross the x-axis, right? Because sometimes if the x is really, really large, I have the third root of a large number, which will give me some large number minus 5, has to be positive, right? So at some point it has to become positive, has to cross that x-axis. So if I cannot find it or I missed it and I'm not sure what to do, what is the equation that I need to set up to find my x-intercept?
You look at the calculator.
I'm talking about equation. If I don't find my x-intercept here and I want to make sure it doesn't exist or did I miss it, I take my function and set it to what? 0. Because in that point, x-intercept, the y value is 0, right? That's how we found it. Remember? Right? Yes. And then when I solve this, plus 5 plus 5, third root of x minus 1 equals 5. What do I do from here? Not root. I already have root. I want to get rid of the root. To the power of 3, right? I cube everything. Both sides. 5 cubed. So x minus 1 equals 125. Plus 1 gives me x equals 126, which is what Isaiah found in the table. Right? Make sense? Okay. So increase in interval. Where is my function increasing? For which values of x? Huh? Negative infinity to infinity. And decrease in interval? None. Everybody good with increasing, decreasing? Left hand behavior. What happens to my y on the left?
Negative.
Y goes to negative infinity. What happens to my y on the right? Positive infinity. Very good. Questions about this example? Okay, so this one is almost exactly the same. We'll just do the first step together and then you can work on your own again. So, don't confuse this with polynomial, right? The exponent is rational. We have the fractions there. So let's rewrite it in the radical form. What do I write? Leah, how do I rewrite this in radical form? So that it looks like something we are doing today. X plus 3 to the power of 1 over 2. How can I rewrite it? Say again? What is the power to 1 over 2 means? Yeah? So square root of x plus 3 and then minus 4. So this is the function that we want to graph and look at it for properties. No, I'll just silently do it and you can check your answer.
That's good.
R.
Mm?
For the y-intercept, do you want that decimal?
Yes. For this one, yes. Oh, can you tell me?
So
It
don't
is-
don't instantly go to this
Oh,
one.
no,
Do the
right.
decimal.
Yes. Isaiah, why are you packing? You already packed. What do you mean you're not